So example 1 tells us that we are supposed to be looking at this graph, and I've put some relevant points on there just to make it clear because, you know, no grid, and changing it into -3 of g of x. So that's the -3 is outside the function, which means we're looking at changing the value for y. Now, the most important thing to start with is to get those points that hit right in the crosshairs of the graph so that you get a really clear value for the points. So we've done that. We've listed them here in the original y equals g of x. So what we want to do is figure out what they would be if we were to apply them to this -3g of x. So remembering that, using my little handy-dandy cheat sheet, I remember that if I'm, oh, here it is, handy-dandy cheat sheet. It says on there that if I've got something outside the function, then I'm going to multiply this by the y value to get my new point. So I could even make a little point here that says I'm going to take that -3 and multiply it by the y and get my new point. So the x is going to stay the same. I'll leave the x at -2, but -3 times -3 is going to get me 9. So that means that my new point is -2 and 9. I'm going to do the same thing moving on. -1, the x stays the same. I'm not changing it because there's nothing happening inside the function at all. But I'm going to multiply -3 by my y value. But in this case, -3 times 0 is still just 0. So that's going to be kind of an anchor point for us. Now this one, x stays the same. -1 times -3 gives me +3. And x stays the same. 0 times, no one cares, it's 0. This one stays as 2. -3 times -3 gives me 9. So looking at these points, it makes sense that I'm going to have the same value because I've got this 9, 0, 3, 0, 9 pattern, so it should be comparable. So when I go to plot these points then, I can, let's start with 2 and 9. 2 and 9, uh-oh, way up there. And then 1 and 0, same spot. 0 and 3, here's my 0 and my 3. -1 and 0, same spot. -2 and 9, way up there. So I'm going to draw a little bit of a sketch through here to make it clear that these points are present, and then this part, whoops, make a big mess, comes up like that, comes up like that. So you can see that it's been flipped over the x-axis, which makes sense because the negative's on the outside, which is what we learned last section. And the points have been stretched a factor of 3. This used to be 1, now it's a space of 3, and these guys as well. So you can see how using the pattern just to get your new points and then plotting the new points shows you what happened here. We've got a flip over the x-axis, which we could have predicted because of the negative, and we've got a vertical stretch of 3, which we also could have predicted because the 3 is on the outside of the function.